Hello everyone and welcome to my latest Rust Quickie. In my previous Rust Quickie I have talked about how to work with references in Rust, and today I want to continue that discussion by talking in more detail about so-called mutable references, which you need when you want to change data that you are passing into a function by a reference. So let's switch over to Visual Studio Code, where I want to demonstrate that concept in more detail to you. I have here a very simple function, and in the first step I'm allocating here a vector. As you already know, a vector is always allocated on the heap, and therefore there can be only one possible owner of that variable databases. I'm defining here that variable databases as mutable because I want to be able to change the content of that vector. We are pushing here some elements into that vector, and therefore we have to define that variable databases as mutable. And now imagine we are passing that variable databases into a function because we want to change that vector inside that function. I have defined here a function called print vector mutable references, and as you can see I'm passing in that variable databases now as a mutable reference. So it's just not a normal reference, a read-only reference, as you have seen in my last quickie. No, today we are passing in a mutable reference, and therefore that function can also change that variable. As you can see from the function signature, we have here also the mutable keyword, and therefore we can now change that variable. As you can see, I'm pushing here another string into that vector. That push operation changes the vector, and of course the sort operation also changes the vector. And both two method calls are only possible because we have defined here that vector, that reference, as mutable. When you don't define it as a mutable reference, the Rust compiler would generate you here a compile time error. And afterwards we are just printing out the vector to the console. So let's run that one. And as you can see, we have now four string elements in that vector. So we have the initial values of SQL Server or Oracle MySQL. Inside that function we have added PostgreSQL, and afterwards we have sorted that vector, and you can see here the sorted output. And after that function call, again, the variable databases is still accessible, and therefore we can also print out the len, in our case 4, to the console that you can see here. So this is very, very important when you pass a value into a function and that value is allocated on the heap and you want to change that value within that function. You need a mutable reference. If you don't define that reference as mutable, the Rust compiler will just give you a compile time error. Let's talk now a little bit more about that function that we have implemented so far. Imagine in that function print vector mutable reference, we want to print out the initial state of the vector, then we are making changes to the vector, and then we want to print out the state of the vector again. So in my case, I'm just looping over that passed in string vector. I'm printing out the individual elements, then we change the vector, and afterwards we print out again the changed vector. As you can already see, this doesn't really work. We are getting a compile time error from the Rust compiler. When we try to run that program, you can see we have an error, and we have here a problem. As you can see, the Rust compiler tells us that we need a fresh reprover of the variable string vector to be able to change that later. So what happens here? Well, the answer is quite simple. When we perform here that for loop, the Rust compiler transforms the vector internally into a so-called iterator. So the Rust compiler is generating a code like that one. It just generates an iterator from that string vector. So the owner of the string vector is afterwards the iterator. So the iterator owns the memory on the heap, not the variable string vector anymore, and therefore a move operation occurs. So the heap memory, the owner just moves from the string vector variable into the iterator variable. Means the string vector variable is after that first for loop uninitialized, and therefore we are getting here an error when we try to access an uninitialized variable. So this is also a common problem, a common pattern that you will see over and over again when you are working with Rust. And the solution to that problem is to create a fresh repo. So how is that working? Well, it's quite simple. We just perform a repo of that reference that we are passing in. So we are passing in a mutable reference, and we just repo that reference, a read-only repo. So I'm defining here a read-only reference of that variable string vector, and that read-only reference is stored in the local variable temp, and then we can use that local variable temp to perform our iteration. So the Rust compiler again internally generates an iterator. So the owner moves from the temp variable into that iterator variable, but this doesn't matter for that code anymore because we are not accessing that variable temp anymore. Means our variable string vector will be still accessible after the loop. So when we try to run that code again now, you can see now we are able to print out the state of the vector before we have performed our changes. Then we are performing our changes, and we are able to print out the state after those changes. So those repo operation of a reference is also very, very important and quite common when you're working with references in Rust. So please bear that in mind. I hope that you have learned today a lot about mutable references, and next week I want to continue that discussion by talking more about mutable references, about read-only references, and how they can exist together within your Rust code. So thanks for watching, stay tuned, and see you next week again. Thank you.